Assalamualaikum and a very good day class. So now we are in week 2 part 2 video, which is still under chapter 1 first order ordinary differential equations. But for today, we'll go to the separation of variables. In this week, you need to know how to determine and find the general solution of separable equations. Now we go to the definition of separable equation. If we have a first order differential equation, we can say that it is separable if we can write that differential equation in terms of dy dx equal to gx hy. Means that here you can separate these terms, which is the independent variable you can write in terms of one equation multiply with another equation of dependent variable. Means that originally we have actually dy dx equal to function of x and y. And if this function of xy, you can factorize to get gx multiply with hy, we said that that differential equation is separable. So it is called like that because the equation can be rearranged such that all terms involving here dependent variable appear on one side and all terms involving the independent variable appear on the other side. What does it mean by this definition? It is actually when you have this kind of separable equation, when you can write your differential equation like this, means that here for this one, it's referred to, I can write my equation in terms of hy, means that this hy I move to this side, dy will be equal to gx dx. So you can see here, the dependent variable appear on one side, on this side, and the other independent variable appear on the other side. And when I want to solve this equation, I can integrate both sides. That will give us the solution of ODE. Means that here, when I integrate both sides, so I can get the solution of the ordinary differential equations. So class, we go to this example. In this example, you need to identify whether these two differential equation is separable or not. We look first for dy dx equal to y to the power of 3x exponential of 2x plus 4y. In this case, can we write this equation in terms of hy multiplied by gx? So let's resolve this one. If we have here dy dx, okay, we have y to the power of 3x exponential of 2x plus 4y. I can write this one equal to y to the power of 3 x exponential of this one, you can use actually power law, which is we can write in terms of exponential of 2x. When here plus, actually it is multiply with exponential of 4y. So in this case, I can rearrange this equation such that the variable y is located together and variable x is located together. So here I will have here y to the power of 3 exponential of 4y. This one multiply with x exponential of 2x. So here you can see this one in terms of hy, function that only have y variable, and this one function that only have x variable. So in this case, when I can write in terms of the definition of separable equation, this equation is a separable ODE. So here it is separable. But for the second one, if we see here dy dx equal to 3y plus sine x. When you look at here, we are unable to factorize this one such that we can have in terms of hy times gx. So in this case, it is non-separable equation. Next class, we go to this example. You need to identify whether the following is separable differential equation or not. So we look for the first one. First one, we have dy dx equal to y plus 8x squared equal to y. In this case, I can write here dy dx equal to, I can factorize this side such that I have y times 1 plus 8x squared. So this one is my hy and this one is my gx. Means that it can be written as the definition of separable equation. So for the first one, it is separable. Next, we go to the second one, which is here dy dx equal to x plus 3y divided by x. This one, if you see, we actually unable to write this equation in terms of hy times gx. Means that you unable to factorize this equation so that it is non-separable equation. Okay. And then for the third one, I have this one. Okay, for this one, I can write my dy dx. If you see, it is quite similar with the previous example. This is exponential function to the power of 2x plus y. If here plus means that actually we can write exponential of 2x times exponential of y. So in this case, means that this is my independent variable equation and this is my dependent variable equation. So that this one is gx times hy. We can write in terms of the equation given by definition of separable equation, means that this one is separable. And then class, we go to the fourth one, which we have here sin x cos y dy dx plus 4 cos x sin y equal to 0. So in this case, I can write this equation, okay, this dy dx equal to, I move this one to this side. So I have negative 4 cos x sin y. And then this one I move also to this side, which is divided by sin x cos y. In this case, I can actually factorize this equation, whereas I have here negative 4 cos x sin x times sin y cos y. If you see here, this one I can say that it is in terms of gx and this one in terms of hy, means that for this case it is separable because we can write our equation in terms of dependent variable terms times independent variable function. Next class, we go to this example. Identify whether the differential equation dy dx equal to 3x plus xy divided by y squared minus 1 is separable or not. So in this case, we can check here. This one is separable. Why it is separable? Because for this case, I can write here dy dx equal to, I can factorize this x. Okay, so I have x here, 3 plus y divided by y squared minus 1. So I have here x times 3 plus y divided by y squared minus 1, whereas this one is my gx and this one is my hy. So I can say that it is separable equation. So this class is how you can identify whether that differential equation is separable or not. If that differential equation is separable, means that we can use the method that you will learn later to solve this kind of differential equation. But Before this, you have know how to identify is it that equation or that ordinary differential equation can be classified as separable or not. But today, we'll go how to solve that separable equation. So here there are two steps. The first step, you need to rewrite the equation in terms of separable equation. Means that if you have your dy dx equal to function of x and y, you need to factorize this function such that it can be factorized in terms of gx times hy, and then you can write that function which is the dependent variable term is the right hand side and the independent variable term is located at the left hand side. And then class step number 2, once we got this one, we can integrate both sides of this function to get the solution of the respective ordinary differential equation. So class, we go to this example. Solve dy dx equal to 1 plus y squared. In this case, if you look at here, you don't have term x. Means that actually it just multiply by 1. So in this case, we can write our equation in terms of separable equation. Means that we have our dy, which is divided by 1 plus y squared, which is this dx we move to this side, so equal to dx. How to solve this one? You need to integrate both sides. Means that I integrate here both sides so that integration of this part, you can see the function is quite complicated. But how can you integrate this part? Actually, you can refer to mathematical formula book, which is when we integrate, okay, integration of 1 plus y squared dy from the mathematical formula book, we can get the answer at tangent y. Okay, so that's why we got here the arctangent y. And when we integrate this one, we got here for this part integration of dx. Actually, here it is like integration of 1 dx. So this is constant. When we integrate this one, we will got here integration of 1 dx. You got x, and then you need to plus with the constant c. It's like what we have learned in week 1. So here, when I solve this one, for this part, I got arctangent y. So I have here arctangent y equal to x plus c. But you cannot leave your answer like this because you have to make y as a subject. Means that you need to move this arctangent to this side. This one is arctangent. When we move to this side, so we got here y equal to tangent, which is put here all in the bracket, tangent x plus c. This is our final answer. And then class, try to solve this differential equation. So here we have x dy dx equal to 1 plus y. In this case, I can write here this differential equation as separable equation. So my step number 1, I have dy divided by this 1 plus y, we move to this side, and all x and dx we move to this side. So I have dy divided by 1 plus y equal to this one go to this side. So I have here 1 over x dx. Means that first step here, I have, for example, I write dy dx equal to this side I have 1 plus y. I move first this x to this side, so it is divided by x. And then once I have this one, I can move this 1 plus y here, and dx I move here. So I have dy divided by 1 plus y equal to 1 over x dx. This is our step number 1. And then step number 2, we need to integrate both sides. So we integrate 1 over 1 plus y dy equal to integration 1 over x dx. Actually, class, this is a basic integration knowledge that you need to learn from calculus. That's why applied mathematics is advanced topic, which is the basic prerequisite for this subject is calculus. You need to know how to differentiate function, and also you need to know how to integrate function. For this part, when we integrate here, we integrate 1 over 1 plus y here dy respect to y. Integration this one, you will got here ln 1 plus y. Why here we have absolute value? Because ln function, this term cannot be negative. It should be positive. If it is negative, it will be undefined. And then class, when I want to integrate this side, which is integration 1 plus 1x dx, it is directly, you can base on the mathematical formula book. You'll got here ln x plus c. So in this case, when I substitute all this in this integration, I solve this integration, I have ln 1 plus y equal to ln x plus c. I write it again. Previously, we have ln 1 plus y divided by ln x, which is equal to c. Based on logarithm law, we can write it ln 1 plus y divided by x, which is equal to c. When we have this one here, again, the next step, you need to write y as subject. So you need to move this ln to this side. Means that you will have here 1 plus y divided by x equal to exponential of c. Okay, because when this ln we move to this side, it's become exponential function. When I move this x to this side, I will have here 1 plus y equal to x times, let's say I write the exponential of c as a, because it is just constant. Let's say we put here it's just a constant a equal to exponential of c. So I have here a times x, and then y, which is this one moved to this side, I have ax minus 1. So this is our final answer for this solution. Means that for this ordinary differential equation, by using separable method, y here is given by ax minus 1. Class, we go to this example. Now we want to solve this x dx minus y squared dy equal to 0. In this case, let me check for the first step, number 1, whether we can write this equation in terms of separable equation or not. If you see here, this one already separate. So I have here negative y squared dy equal to negative x dx. Means that I can write y squared dy equal to x dx. How can we solve this one? We go to the second step, which is we need to integrate both sides, which is we have integration of y squared dy equal with integration of x dx. It is easy to integrate this function because this function is just polynomial function. So integrating of y squared dy will give us y to the power of 3 divided by 3. And integrating this side will give us x to the power of 2 divided by 2 plus c. And then class, again, we need to write this equation in terms of y as subject. When we move this 3 to this side, I will have here y to the power of 3 equal to 3 times x to the power of 2 divided by 2 plus c. So we will have here 3 over 2x squared plus 3c. And then remember this one, this side should be in terms of y only. We have here power 3. Move this one to this side, we'll got y equal to 3 over 2x to the power of 2 plus 3c. Here should be power 1 over 3. Because here power 3, you move to this side, so 1 over 3. This is the final solution for this example. Hi class, we go to the next example. Previously, you have learned how to solve ordinary differential equation using separable method, but the problem that you got, there is no initial condition. But now we want to solve the initial value problem. Means that you have equation of ordinary differential equation together with its initial value. Here we have the problem of dy dx equal to y minus 1 over x plus 3, whereas here we have additional information that is y negative 1 equal to 0. If you back to the week 1 slide, so in this case, you can get particular solution instead of general solution. Means that previous example, you got general solution, but now when we have additional information here, which is initial value, so you will got the solution here in terms of particular solution. Now class, we will go one by one how to solve this problem. So the first step, you need to write this equation in terms of separable equation. You can actually move this y minus 1 to this side and dx you move to the other side. So we will have here dy divided by y minus 1 equal to 1 over x plus 3 dx. And then step number 2, we will integrate both sides here. And actually this one, where you got 1 over something function or 1 over some function, means that the answer should be in terms of logarithm. That is here. We integrate 1 over y minus 1 dy. You will got here ln, okay, y minus 1. And then integrating of 1 over x plus 3 dy. So we'll got here ln x plus 3. Instead, in this case, you have to put here c. Okay, because at first, it is in terms of general solution. But later, you can substitute initial value problem to get particular solution. Means that for step number 2, by integrating of 1 over y minus 1 dy, which is equal to the integration 1 over x plus 3 dx. We'll got here this part ln y minus 1 equal to ln x plus 3 plus c. And then class, remember, you cannot leave your answer like this, but you have to write y as subject. How to write y as subject? First, we move this ln to this side. We collect all ln with, at the same side. So here we will have ln y minus 1 minus ln x plus 3 equal to c. And then remember, law of the logarithm, when this one is minus, we can write in terms of division. So we will have here ln y minus 1 divided by x plus 3 equal to c. And then class, remember previously we have the same kind, the same pattern of the solution like this. This ln you need to move to this side. So you will have here y minus 1 x plus 3 equal to exponential of c. And in this case, I can write this exponential of c as a constant a. So I will have here y minus 1 x plus 3 equal to a. And then I can move this x plus 3 to this side. I will have y minus 1 equal to a times x plus 3. And then I have here y minus 1 expand this function ax plus 3a. When I move this negative 1 to this side, I will have here y equal to ax plus 3a plus 1. And then class, you have previously initial condition. which is initial condition is given by y negative 1 equal to 0. Remember, this one is the value of x. When x negative 1, you have y equal to 0. So we need to substitute x and y here in this equation so that when we compute, we can get the value of a. In this case, I substitute x here with negative 1. I substitute y with 0. I have here 0 equal to a times negative 1 plus 3a plus 1. In this case, I can solve this one. It is actually 3a minus a. So I have 2a plus 1 equal to 0. When we solve this, so I write like this, 2a plus 1 equal to 0. I have 2a equal to negative 1. I solve for a, so a equal to negative 1 over 2. And when we got this one, means that to get the particular solution, this a, you need to substitute in this y. So we will have here our solution y equal to negative 1 over 2x plus 3 times negative 1 over 2 plus 1. In this case, you can solve this part, okay? Which is we have here equal to 1 over 2x plus, minus, because here plus minus 3 over 2. This one make a denominator equal, so it is plus 2 over 2. So our final solution y equal to 1 over 2x plus, minus 1 over 2. So this is our final solution. Sorry class, here I miss here negative 1 over 2. So negative 1 over 2x minus 1 over 2. This is how can we get a particular solution using separable method. Next class, we go to the application problem. Sometimes I will ask you application problem instead of general mathematical problem. So now we go to this application problem. We have, for example, the population, which is this population is denoted by notation P of a town. We said the population of the people in one town is initially, at initial time, is 7,000 people only. And it is growing at a rate of dPdt, means that rate of change for that population with respect to time is equal to 0.08 people per year. So the question asks you to find the town's population in 10 years. How to get this one? You need to find P, population at time 10. So we want to compute the population of the people when this t equal to 10 years. So here, what is the number of this population? How to get this p? Because now you have here in terms of the PDT, means that you need to integrate the function. Okay, integrate the function, or means that you need to solve this ODE. How to solve this ODE? So class, we have here dp dt equal to 0.08 p. So now we use separable method. So we can move this one to this side and this dt to the other side. Means that for step number 1, I will have here dp over 0.08 p will be equal to dt. In this case, when we integrate both sides here, okay, I will have this one integration of 1 over 0.08 p dp equal to integration 1 dt. So integrating this part, remember, we can write here as 1 over 0.08 integrate 1 over p dp equal to integrating this one, you got t plus c. Okay, and then when we integrating this part, we will have here 1 over 0.08 ln P equal to T plus C. And then I can move this 0.08 to this other side. So I will have here ln P equal to 0.08 T plus 0.08 C. But this one, I can just write in terms of A. So I have here ln P equal to 0.08 T because this one just constant, okay, which is plus A. And then class, remember we need to write at this side at just P. So we need to move this ln here. So I have P equal to exponential of 0.08 T. When I move this ln to this side, for this one, it's become actually exponential of A. Okay, because this one, the rule of exponential is become multiplication here. And for this part, I can write this one, for example, as another constant K. So I will have here P equal to K exponential of 0.08 T. Now, I got this solution in terms of general solution. But already given to us a time here. Okay, the question asks the value when we have here 10 years. And in the question, we have actually initial value. Based on this, you can extract the initial value from this information. Means that initially there are 7,000 people. When we mention this one initially, so at this, our time is equal to 0. Means that the population of the people initially is 7,000. So I can transform into mathematical term, which is the population of the people at 0 time, it is equal to 7,000. So you can use this information to get the particular solution of this problem. So that class what we have got previously, we have here P at initial, there are 7,000 people. We have solved the ordinary differential equation, whereas P we got equal to K exponential 0.08 T, and the question actually asks the value for 10 years. What are the population of the people in that town? So now, before we find this one, you need to find the value of K based on this initial value. Because now you need to find a particular solution so that you can get the P at 10 years. How to get this? Okay, so we have here T equal to 0, P at 0 equal to 7,000 people. Means that when initial is time is equal to 0, this P we can substitute with 7,000 people, which is equal to K exponential of 0.08 times 0, which is T here we substitute with 0. In this case, this one exponential of 0, you use your calculator, you will got equal to 1. Means that directly we can get K here equal to 7,000. So based on this, we will have your particular solution P equal to P at time T will be equal to 7,000 times exponential of 0.08 T. So now class, when we know that we want to find population at T equal to 10 years, we will have here P at 10 years will be equal to 7,000, and this T you need to substitute with 10. Okay, when we solve this one using calculator, we'll got here the answer equal to 15,578 people.